Okay, so I'm gonna try typing today and make this a little bit bigger. So today we will talk about Frobenius maps. Okay. Um, so imagine you start with a finite field. So that literally just means okay, FQ. Okay, so finite that just means there are a finite number of elements in the field. Um, Actually, exactly Q elements. Yeah. Okay. Um, so meaning any element, call it K, of FQ. Okay, when raised to the Q power, becomes itself again. So it's the case that if K in FQ, then K to the Q power is equal to K. Okay, so that's an identity. Okay. Also, make sure that Q is equal to a prime raised to some n power. Okay, so Q is equal to some P to the n, where P is prime and obviously n is an integer. Okay, cool. Now, so to repeat, K to the Q is equal to K when you do arithmetic in this field. Okay. All right. Now, the Frobenius map, the Frobenius map called FM, takes in an element and raises it to the Q power. Okay. Now, no matter what element R, so if R in Q, then the output of FMR is equal to RQ. Now, that's interesting because RQ is actually also equal to R. So this is literally just the identity map. Every input results in the same, every input results in the output, the output that comes out is the same as the input that goes in. So not very useful. Okay, so not very useful. Now, however, if you take the algebraic closure of FQ, so suppose the algebraic closure of FQ is denoted FQC. Okay. Now, in general, if you have some random y element of FQC plugged into FM, the output is not the same as the input. So FM, FM y is equal to YQ, which does not equal Y. Okay, because this is the algebraic closure that we're working with. Okay, some random element Y, it's in the algebraic closure. It does not have to be in Q. It's an FQC, which could also be in FQ, but it's not in F. But usually it's not in FQ. Okay. So yeah, that is the definition of the Frobenius map. And in fact, the Frobenius map Fm is an element of the Galois group known as G FQC over FQ. Okay. And repeated applications of the Frobenius map of Fm generates the entire Galois group. And yeah, that is it.